So in the last class, we had seen certain properties of solids. Today, we'll be looking at certain properties of fluids, that is, liquids. So we'll see two important properties of the fluids. First of all, we'll see the pressure. Then we'll see surface tension. Oh, so let's start now. I hope the screen is visible. Stacy, is the screen visible to you? So we'll be studying two important properties, that is surface tension and viscosity. So we'll observe certain natural phenomena and then we'll try to understand what is surface tension. Okay, Shreya, even if you are not able to speak, so in the same way, you can message whenever you have any doubt. So since right now you are only there, would you like any previous topic or shall we continue further with this one only? I think we should continue with this surface tension. Okay. So see, surface tension is the property of the liquids by which the upper surface of the liquids, it appears or it behaves as a stretched membrane. So how it behaves, see, the property of fluids due to which the upper surface behaves as a stretched membrane, as a stretched membrane. So how it behaves, let us see. All the liquids, they have this property. See, suppose if you take, and this property will explain a number of phenomena. So you have water in a beaker. Now what this says, it says that in the layers of water, suppose you have filled this with water. So the upper surface, the top layer of the water, it behaves as a stretched membrane. So how do we observe it? If you take a paintbrush needle and put that brush needle inside water, so you will see all the bristles, they are clear apart. They will be far apart. But if you pull out those paintbrush outside water, you will observe that all the bristles, they stick together. So I'll just show you with the diagram what I'm telling here. See? Uh, I'm observing now bristles in water. Uh, Okay, see, this is what you will find. See here, this picture.
Sir, I'm audible now?
Yes, you are audible now.
Yeah, yes, I understood.
So you can see you have the paintbrush bristles which have been dipped in water, and these bristles, they are stretched. When the bristles are out of water, you observe that all of them, they stick together. So it's something like this. You observe here also it's some here. So if they are in water, all the bristles, they will be separated. And if you take them out, so all the bristles, they will stick like this. Similarly, depending on the surface tension, there are certain other phenomena like the formation of bubbles. Okay. So why we see the formation of bubbles? Over there, we observe a very thin film of water molecules. So the thin film of the water molecules, it shows the property of surface tension. And that is the reason the bubbles are formed. So welcome Jaswant and Dhanunjay.
Good
Also,
afternoon, sir.
Good afternoon.
good afternoon. So see, I'm explaining about the property of fluid, which we call as the surface tension. Okay. So, okay. Here, the property of fluid due to which the upper surface behaves as a stretched membrane. We observe that the upper surface, it behaves as a stretched membrane. So it is something like this. Suppose if you observe the upper surface of water, so we can imagine the upper surface of water is being stretched. So this property is explained with the example with this activity that when the bristles are in water, all the bristles, they do not they experience equal amount of forces through each other, so they are expanded apart. But when they are outside of water, so there is a film of water just on the outer surface or outer surface of the bristles. So the film of water, it the film of water, it is stretched. It is like a membrane. So it tries to occupy the minimum surface area, and hence it holds all the bristles together. So
Then what
therefore,
about
all
the
the
bubble formation, sir?
yeah, in the case of bubble formation, we observe the phenomena of excess pressure. See what happens in during a bubble. Okay. So you take an air bubble. Now what happens in the air bubble? You have this air bubble is made up of very a thin layer of water molecules. So the water molecules, they are there just on the surface. So here the question comes that why a bubble is spherical in shape? Why a bubble cannot have any other shape? Why it tries to have a spherical shape only, right? So you can assume that there is a very small or very thin layer of the water molecule surrounding the bubble. You have air inside it and air outside it. Inside the pressure is high, but outside the pressure is low. So what happens here? The molecules of water, they try to stretch this membrane. They try to occupy the minimum surface area. It's something like this, just like you observe the membrane of a tabla membrane. So it is stretched from all the sides. A tabla membrane is stretched from all
Yes,
the
sir.
sides, and if you loosen it, so it tends to occupy the minimum surface area. Yes, all of it comes close to each other. So here also it seems that the molecules of water. So also we can understand something like this. Let us say this be the outer surface of layer of water. So I'm making this, suppose for this one only, this is the upper layer. Now on the upper layer, if you draw any imaginary line, so it seems that the water molecules which are on the both sides, they seem to be pulling this line towards each other. So they feel like they are pulling this line towards their sides, and hence it seems as if we have stretched the membrane, we have stretched the top layer of water. Okay, where and the molecules are tending to collapse. They are tending to collapse the outer surface. So similarly here also, in the case of bubble also, the molecules are trying to collapse. They are trying to occupy the minimum surface area. And mathematically it can be proven that a sphere has the least surface area. For a given volume, a sphere will have the least surface area. Okay, so this I'll explain this property also, that for a given volume, a sphere has the least surface area for a given volume. So it is for a given volume, a sphere has least surface area. Okay, so here, if you observe a sphere or any other shape, suppose I want to put up 2 liters of water. Okay, so I want to put up 2 liters of water in a sphere. I want to put up 2 liters of water in a cylinder. I want to put up 2 liters of water in some other shape, in cuboid. Okay, and also calculate their surface areas. So I will find out that the sphere will have the least surface area out of them. Okay, so that is the reason all the soap bubbles, all the air bubble or soap bubbles, they will be spherical in shape, because a sphere will have, it will include the same amount of air. The sphere will include the same amount of air with minimum surface area. So the membrane would occupy the minimum surface area. Got it? So this is the property of surface tension. We can explain it with the bristles, with these soap bubbles. There are certain other examples which demonstrate the surface tension. Now see how we can demonstrate by another. We can take a needle. As you know that a needle can sink in water. A needle will always sink in water. Its density is higher than water, right? Okay. So density of needle is higher than water, and hence if you put this needle in water, this needle will sink. Okay. This needle will sink. Now, if I want this needle to float, I can make the needle float on the surface of water. Okay. So how it is possible that I can make the needle float on the surface of water? Okay. That is by, if I apply a small amount of oil or grease or wax, I apply a small amount of wax, oil, or grease, any of the substance on the surface of needle, so that that is not to decrease its density, but it has some other purpose. Okay. So what will happen if I gently put it on the layer of water, on the top surface of water? If I gently put here a needle, so the needle cannot sink. The needle will float. If I gently put it over here on the surface, so that it does not pierces the uh, upper layer. If it pierces the upper layer, so it will sink. But if it does not pierce the upper layer, pierce the upper layer means you have to put it very gently, so that the upper layer, which behaves as a membrane, it should be intact. Okay, so that why we
Sir,
applied.
is it
Yes,
because of this property boats float on water?
No, boats float on water. That is because of density.
Okay. Okay, sir.
That is density. Here we are just talking of surface tension. So
Yes.
even the needle can sink, but if you drop it, if you do not drop it, put it gently. Rather, if you drop it, so it will go down and it will sink. But here, if we put it gently, so that you can say it's just like a leaf-like structure. The upper surface behaves like a separate structure, separate membrane. So the needle will keep floating unless the water from all the sides comes and overlaps. So that cannot happen since we have covered the needle with wax. So water cannot come above. And hence the membrane will remain intact. Therefore, it cannot sink. It will be floating. Another such example is a rising of water in a capillary tube. That is also an action which is due to surface tension. So, it's capillary action. Next one is capillary action. So, capillary action means if you have pipes which have very thin diameter. So, you are having pipes which have very thin diameter like this. And if you put a drop of water over here, water, oil, or any substance over here, and just put this capillary, this is called as capillary, put this capillary on the drop. So the water level here that will rise up this capillary tube on its own. You need not suck it up. There is no need of sucking it up. Rather, the water level will rise up on its own. The water will start rising on its own. So this property is called as capillary action. So we can observe capillary action here. Got it? Now, how it happens? We'll discuss this about the capillary action. There are some other forces also involved, which we know as forces of adhesion and cohesion. So they are also involved. But this is an important phenomena of surface tension. So let's see some other phenomena which are related with the surface tension. Okay. Uh, let's see some phenomena which are this one. We discussed the formation of bubbles. The bubbles are formed due to the surface tension and they have their shape. The shape of the bubble is spherical, that is due to the surface tension. Due to the surface tension, the membrane of the bubbles, it tends to have the spherical shape. Then we see some other ones, some other phenomena. Yeah, this one, the alpine floating. See, I was just discussing about this, the floating alpine. If you put the alpine, if you drop the alpine in water, it will sink. Okay. But if it is supported by the surface so that no water flows above the pin, so it will keep on floating. That is, it will not be able to pierce through the surface. Okay. So that is again due to the surface tension. Let's see some other phenomena. Mm, Yeah, this one capillary rise. See, I was just discussing about this capillary rise. So if you have a thin tube, which we call as the capillary, the water which is there that helps it to rise up. So water the surface tension of water. That means it is the surface tension. How it happens that we will see later. But see, the region again here is the surface tension. Surface tension, you have understood that it is the property of all the fluids by which their outer membrane, it behaves as a stressed membrane. Outer surface behaves as a stressed membrane. Yeah, two other phenomena also we observe, which that is due to surface tension, and that is we have meniscus, formation of meniscus. See, whenever you have seen the diagram of water, so here you will observe the diagram of water, or anywhere if you have observed, even if you do it practically in your laboratory. So you will observe the water in the capillary. It forms a curve like this. It forms a downward curve like, okay. But if you observe for mercury, so for mercury, this for mercury or some other substances, it is not downward. For mercury and other substances, their surface tension is very low. So they have this phenomena. They form their meniscus like this. They form their meniscus
Yes.
something like this, upward. Okay. I'll just show you for mercury also. So for mercury, the meniscus is upward. And this phenomena is also due to surface tension. All right. All right. Okay, see, for mercury we have the formation of meniscus like this. It is in the upward direction. Right? Okay. So these were the phenomena of surface tension. Now we observe the other phenomena that I told you we'll be doing that one. That is viscosity. So viscosity is something, it is the property of the fluid by which it opposes the movement of the fluid itself, by which it opposes the movement of substances through itself. That is called as viscosity or backward drag. So I will explain this in simple words also what it means. It is the property of liquids due to which it opposes the flow of substances, flow of materials through it. So this property we call as viscosity. In simple words, suppose if you want to move something through honey, if you want to move your spoon through honey, and if you want to move your spoon through water. So moving your spoon through honey is more difficult as compared with water. Okay. So it is because honey has more opposition, and that opposition is the backward dragging force, which we can also call as the friction of fluids. So it can be understood in a simple way if we consider the liquids to be like this. If we consider the liquids to be made up of certain layers, so the first layer, you will have the second layer, you will have the third layer, fourth layer, and so on. The liquid is made up of these layers, and hence these layers, how the liquid moves in the form of layers. So when the upper layer moves, so this layer offers a resistance. The lower below it offers a resistance to the upper layer. Okay. Due to the friction between the two layers, there is an opposition. So the first layer or the top layer will have the highest speed. The layer just below it will have lower speed. The layer below it will have still lower speed, and so on. So the speed will go on decreasing down. So this property is called as viscosity. The property due to which the fluids show this property, that is, they are able to oppose the motion of the layers. This property is called as viscosity, and viscosity is study of viscosity is an important phenomena when we study about the engine oils. When we study about the working of engine oils, how do the engine oils work? Okay, so that property is also based on the viscosity. We study how viscous the liquids are. So depending on their viscosity, a proper engine oil can be chosen. So engine oil should not be very viscous. It should allow the movement of the substances. It should not get heated up quickly. It should act as a good lubricant. So there are different properties that can be defined for a viscosity. Okay. The viscosity is not only for liquids, it is for all the fluids, even for air also. So air also acts as a viscous medium. That means if any substance passes through air, suppose this is your liquid, and in this liquid you drop a ball from here. So what will happen? This ball will move downward, but the upper layer will try to oppose its downward motion. The upper layer will move down along with it. So on as the ball will move down, so it will be something like this, that each layer it will be formed, the layers will get accumulated, and hence they will oppose the motion of the ball. Okay. So this is again due to the property of viscosity. When the substance is highly viscous, it will offer more dragging force as compared with the low viscous substances. So anyone having any doubt?
No, sir.
Okay. So with the liquids today we have done these two important phenomena, surface tension and viscosity. We'll see some more diagrams which explain us the viscosity. See, this is what I was talking of. The substance is divided in layer by layer. So the upper layer will be moving with a higher speed, and when it moves, it tries to move the layer below it, but the layer below it opposes it, and hence there is a big viscous drag. There is a